All right. Testing 1, 2, 3. Hey, this is Delta Peng from Peng Tech. Name pending. Just some temporary name for now. Yeah. Welcome. Welcome to this video. I plan on doing a series about computer programming, and my goal is to get you started from zero-ish, zero to up and running with computer programming and being able to, particularly with React website development, and being able to at least get started and create something, create a side project, and start, getting your feet wet with that. In my experience, I feel like this would be probably the best way to kickstart people into the world of computer programming. If you can get them on a side project, get them interested, excited, and then it'll encourage them to, it'll motivate and encourage them to push forward, learn more of the details and the specifics for themselves. But I think a lot of people have a hard time just crossing that barrier and overcoming that initial hurdle. And so my goal is to try to get you there quickly. That said, I majored in EE, electrical engineering, and then later on went on to the software side of things for my career work. But I didn't start there. So because I majored in EE, regardless, the university I was at, all the engineers took some electrical classes, and then everyone took some computer science classes as well. So I still got some exposure to it. I started with C++ and did a little bit of like VHDL, which is like a hardware kind of programming language. From there, I went on to take like a intermediate-ish Java class and a SQL class, and then I got a job. So then it was just work experience. But because of that, some of my knowledge had gaps when I went into the field, and so a lot of it was me working and understanding it some, but not to as great a depth as I was like, and understanding the concepts behind it. And that kind of just came over the years with practice and experience. And that's something I think programming you just have to do to get good at. The nice thing is it's all, it's pretty much all online. You can set it yourself up locally. There's a bunch of resources. So there's definitely a lot of that out there, and technology probably isn't going away anytime soon. So it's a useful skill to have, whether it be for future work or just for your own creative side projects or whatnot. I think everyone can benefit from learning how to program and learning a bit more about it. But for myself, I just kind of had to, I sort of had to work my way through it. And I remember when I was first going through the classes, I passed the classes, but, I got a good grade at it, but I didn't really grasp it. But then after I graduated and I was trying to decide what to do with my life, it was kind of like, I remembered the programming classes I took. I'm like, what, maybe I should, revisit that and try to, look over my old notes and see if I can make more sense of it. And as I did, the light bulb kind of just turned on. I'm like, oh, that's what they were trying to say. That's what they were trying to teach me. And having kind of, I guess, just having gone through it now, I feel like if they had just explained it a little bit differently, it would have made so much more sense to me, at least how my mind works. And and so now I want to try to impart that to you guys and help kickstart you in that sense. At least in my experience, I feel like a lot of university was maybe a lot of the teachers were more like either had heavy accents, and so they were hard to understand, and or they were more like researchers rather than teachers. So like they might have known their stuff or maybe known more like the theoretical side of things. But in my opinion, that doesn't mean much if you can't communicate it to others, if you can't if you can't pass those skills along, then, the usefulness is limited. So for me, I feel like, because since I sort of had to learn it on my own, and sort of wrestle with those concepts, I feel like I learned it better, or I know it pretty well now. And then also just a better way of it. I think I can explain it better maybe than some other people can, since I kind of had to, come from a less technical side and grasp it from there. I also find, like, I don't know, for me, technical documentation can be a bit hard to read. But again, I think the concepts of it aren't too bad. It's just, I don't know, maybe just the way I see it or the way they explain it just isn't matching up for whatever reason. So yeah, so that's my goal. What that means is some of the terms I use, it might not be as technically accurate per se, as a disclaimer and a warning, just, but that's not really my goal at the moment. My goal is just like, from a layman's perspective, can I get you going? Can I get you started? And get you understanding like some of the basics of how the computers work and the programming, how computers work, how programming works, and how the pieces kind of fit together, so that you yourself can start thinking in that way and start building, cool creative projects for yourself. That's basically what it is. It's like Legos for adults. You just, you have these different pieces, and you just need to like figure out what they do, how they work, how they connect to each other. And then from there, then you can build something, then you can build something great and build something digitally. And there's just so much power and potential if you can figure it out. And programming is very interesting because it's like, it works both sides of the brain, in my opinion. Usually there's like, there's the logical, mathematical, English grammar side. And then there's the, creative writing, music, kind of artistic side. And I feel like programming does both. It's primarily logic, but then if you do like website development, it's, the UI is also a factor. The nice thing about programming as well is that it's something that you can always get better at. You can always improve how you write your code and other things like that. So yeah, I don't know. It's just a fun, interesting kind of challenge, puzzle to solve. And yeah. So let's get started. Computer programming, it comes in different flavors. There's called computer programming languages. And so there's stuff like C++, Java, C#, and JavaScript, Ruby, and there's like a database language called SQL that we'll go over later. It's not necessarily programming, but it's related. And so basically what this is computers are devices that, you're aware of, but it's like basically what they do is they can calculate and process things, many times faster than a human can, but it's not able to think for itself and imply or infer things, roughly speaking. Okay. So it's like, this is a standard computer. It's like, okay, it can like run, say, like 1 million math calculations in a second. So that's great. But it needs something to tell it, like, okay, what should I process, or what should I calculate? What should I do? So that's where the computer programmer, that's where we come in, or that's our job, is we gotta write. So code is basically just a list of instructions for the computer to do. Or the computer or the device do. So if you, run this program, then do this command, this command, this command, this command, this command, this command. If they press this button, then do this, 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 this. If they, if it's like a phone, if they shake the phone, or if they turn it to the side, then do this, So that's in essence what computer programming is. Everything that you see in a computer program was designed by someone, and the logic behind it was written by someone. And so why would you want this? For one, the computer's really good at doing, again, monotonous tasks or things, or calculating things, many calculations and faster than a human would be able to do it, and with more precision. So if you can create a program or learn how to code, then you can gain access to some of that that power, I suppose you could say, that that the device can compute for you. But yes, let me show you some practical examples to help you understand. So let me see if I can switch over to my screen. All right, this should be working. All right, this is a computer. This is a Windows OS, or operating system. So that's kind of the code behind the scenes. And if you're familiar with things, here's different icons. Here's different programs that are open. So as an example of a program, we could say a calculator program. Okay. So I clicked the calc executable .exe, and here's what appeared. So this thing is a program. So the computer is running many different things, but because I clicked on the calculator program, here's what appeared. So basically, like when you see this, what is this? And it's like, and you can see my mouse here. This is me moving it, but it's like, okay, there's different standard window things, like you can minimize it, you can maximize it, you can close it out, but that's standard to the window. But what about the program itself? It's a calculator program, right? So what that means is you can say type a number or click a number, so these different buttons. So let's say 7. Okay, a 7 appeared. Cool. How about what's 7 plus 6? Okay, and then if I press equal sign, then it'll calculate it for me. All right, 13. So that's nothing too fancy, right? So, but what if I did like, hey, what if I did like 784 times 61? That's a little bit harder to figure out on your own, right? I mean, you could do it, but it takes more time. But let's see, computer, well, how about you? Okay, press the equal sign, nope, and it calculated it instantly. And so the power and benefit of a computer is that it can do things like this, again, like 1,000,000 times a second or so. It's very fast. And, humans could do it. It's easier to leave certain tasks like this to the computer. But what else can it do? So this is a computer program, and when we click on something, like we click on this button that says 7, as 7 appears. Click again. Okay, now it's 77. So this is kind of like, that's what you'd expect to happen, right? If you click the button, then the number appears, and if you say plus sign, then you expect it to add it to something, right? Well, all of this is not something that the computer would know by itself. All this was programmed by someone. So a computer programmer had to write the logic to say, okay, you type in some numbers when you press it, and then when you push one of these operations, like, okay, minus, and then you do, let's say 50, 55, we'll keep it simple. It should be 22, right? So if I press equal sign, yep, 22. So the computer didn't know, because the computer calculates it, but it doesn't know what to calculate until we tell it to. Until we give it some value or some input, it doesn't know what to give us back, right? We have to give it both numbers, 77 and 55, and tell it what we want it to do. We want it to subtract the two, and then that's when it can give us the result back. So this is a simple program, and then you press this clear, C for clear. Okay, it goes back to 0. Nothing too fancy, right? Well, but what else can a computer do? It can do, let's see, how about something fancier, like a music program. So you have something like this. So computer, let's see. Everything that's happening here is running in, let's say, like a digital space. So like the computer is running on some hardware or some system, and that system is it's using electricity to process these things and give us this calculation, and to show us even to show us like this picture and this image and with this window moving when I click and drag it. Okay. But that's not the only thing it can do, of course. But what about say like a music file? So a file is basically just it's just digital data collected together. So let's click on this one called Green Waves. These are music files. And you can tell that because this is the name of it, 0.green waves, and .mp3 is the type of file it is, what kind of data it's supposed to contain. So if I double click it, oh, okay, nice. So what we have here is music playing, right? So I click a song and then music plays. That's pretty cool. That's pretty amazing, actually. Let's see. Let's try clicking another one. Look at that. So here's different waltz songs that I have. So that is some of the power of a computer. It doesn't just do like calculations. It can also do text. It can also do music. It can also play videos. And why would you want that? Well, part of the reason, other than that's pretty amazing that it can play music. That's already pretty cool. I mean, back in the day, you had to, if you wanted music, you had to either hire someone to sing for you or play a song for you, or you had to do it yourself. But now, because of technology in this digital world we live in, you can have it on your device, and you could create a song, record it, and then it can play it back for you. It's very, very incredible. I know that's some of it might be kind of basic for some people, but that's okay. Work with me. So this is some of the reason why computers are powerful and important, and you would want to make use of them, because it's not just useful for consuming that data. It's also useful for you, especially if you're a creative type. It's useful for you to get your content out there. As an example, like if you wanted to write a note or a journal or something, how do you do it physically? Well, you could get some paper, you can get a pen, you could write some stuff, and then, okay, cool, you have a note or whatever. But what if you wanted to write like a book or something larger, like a letter? It's like, okay, well, I can use the physical paper, I can write it out. But then what if I make a mistake? What if I make a mistake? Well, then I have to either erase it or I have to cross it out, and it gets kind of messy, right? And then even once I'm done, I just have one copy of it, which is okay. But what if I wanted to send the message to, everyone in my family, or 5 people over there, or 100 people over at my church, or something like that? Am I just gonna write it down 100 times? You could, but it's not very, there's a better way. And that's part of the power of computers too. So let's say if I go back to the screen, aside from music, videos, calculations, what else can the computer do? It can also run programs like Notepad or basic text editors, where you can do something like, hey Ma, this is me from, I guess, me from the video. And then I can go files, I can save it. Cool, save, okay. And then I gotta tell it where to go. I guess I'll explain more. Tell it where to go, so I can give it a file name. I want to give it a different name than that. Let's see. Let's say secret file. Okay. If you take a look, let's see. Is it? Nope, there it is. See, it wasn't there before, and now it is. So the computer looked at this and okay, here's some text data. So it did its thing, and it's okay, this is a file program. I want to take this text and I want to save it. So now supposedly this is the thing that I just created. Let's see. Let's try opening it up. So if I double click it or press enter, hey, look at that. It's that same message that I created. Let me see. Can I edit it? And then maybe capitalize that and try saving again. Save. Nope, actually keep that. Don't get rid of that one yet. All right, so I made a change to the secret file. Let's see, take a look again. Look at that. So it saved the changes. So this is like very powerful, because now not only do I have a digital copy of this, I can now send this to other people, and it's eco-friendly. It doesn't, it doesn't use the paper up that I normally would have taken. And when it's digital, if I need to delete something, like, okay, let's say, actually, let me see, if I need to copy something, okay, well, why Ma? Why not also Pa? So, hey Ma and Pa. And then, well, what if I have a nickname? Okay, let's see, how about, hey me Ma, Pa. Okay, what if I wanted to copy it all? I could do something like I could either highlight the section that I want to copy. This is me. And then you can either Control C to copy, or you can right click and then to give you more options. And then, okay, copy. And I can go somewhere else. And this is where it's waiting for new input. I could paste. And look at that. That's the text that I highlighted. If I press Control V, it's the same thing. So I can do, okay, what if I wanted to, what if I wanted a lot of this text? I could, Control V a ton. I could, okay, copy this whole larger text here. And I can, no, look at that. Now I can just copy paste a bunch of things. So the power of digital is that, or what if I had like a password, like, this is a cool but hard to guess password. Gus password. So this is hard because they even, misspelled it. So like if I wanted to like type in this password somewhere, I could do it by hand. I could be like, okay, whoops. I could try to recreate it. Okay, this is, I already made a mistake. I did a lowercase and it's supposed to be uppercase. So you could see, if you could see that it's easy to make mistakes when you do everything manually. But with the power of a computer, instead of this, I can just like, okay, let me highlight, Control C to copy, go somewhere, Control V to paste, and then you get precision, and you get it copied, and you don't have to worry about human error as much. And then you can do other stuff like hook this up to like a printer device, and then you could print, 100 copies of this instead of having to manually write it all out. So this is a sample of the power of a computer and why we should take advantage of that and try to use it for tasks that perhaps are more manual or mundane. If the computer can do it for us, why wouldn't we want that? And why wouldn't we want to use that tool instead of doing it manually? And so that's a preview. So this is kind of like standard user, standard things you can do with the computer as a standard user. But when it comes to programming, then you can start diving deeper into like the cool things that you can do. Because while this is very neat, it's like, if you could create the program itself, like if you could create this calculator program itself, you can imagine just how much more utility and potential and benefit you can get from that. So we'll move to that on the next video.